Hello learners, very good morning. This is your boss man Sagar.Utekar and currently you are watching day 11 of Linux the Funnel Boss series. Today we are going to discuss very important topic which is important not only for your day-to-day activities of DevOps and SRE engineer, but this is the topic which get frequently asked in your interviews as well. So make sure you watch this video till the end as well as complete all the exercises of the challenge. Today we are going to talk about pipes, redirections, wildcards, and links. By the end of this day 11, you will master what are the pipes for command chaining, understand input and output redirections, how to use wildcards for flexible file operations, and create and manage hard and soft links. This will hardly take you to 15 to 30 minutes complete this exercise. Okay, let me explain what are the pipes first, and we can start the discussion from there. So let's first try to understand what are pipes in Linux. Okay, okay. So far we have executed so many commands from day zero itself. So what pipe helps you? Pipe helps you is that to chain those commands. Okay, so this is your command one. Let's say this is your command one. Pipe help you combine this command or create a chain of this command. You can create a chain of the command. Let's say I have these three commands. So what I'm doing with a pipe is that I'm passing output of whatever the command or output I'm getting from command 1 as a input command 2. Okay? Similarly, with next pipe, I can provide the output of second command as a input third command input. So that is what we try to achieve using pipes. Pipes are nothing but chaining commands by passing output of one command to another command. We will see examples soon. Okay. So the next concept which we are going to discuss today is redirection. Redirection. Again, this is one of important topic in Linux and it frequently asked in your interviews. So redirections helps you to send output or input to a file or from file. For example, I have this command. I executed this command 1 and I want to send a output of this command to a file. I want to send a output of this command to a file that can be achieved using redirections. Or I have this another command, command 2, and I want to take input from a file. Okay, I want to take a input from a file that can be achieved using redirections. We'll see that in this in detail when we start um, doing a practical. There are multiple ways. Okay. The third concept which we are going to see today is wildcards. Wildcards. We have seen couple of examples earlier as well. So wildcard helps you to match with a pattern. For example, I want to list only files from my current directory which ends with txt, which is nothing but I want to list only text files from my current directory. How I can do that? So you can use a pattern, star pattern. Star pattern represent anything matching but ends with txt. So this tells a ls command that I want only text based files be listed. Okay, there are multiple different patterns you can that we'll discuss while doing a practical. The last concept which we have already seen is links, soft links and hard links. Okay? Links are nothing but simple pointers. The difference between soft and hard link um, is depends on how it acts at system level that we will discuss during a practical. But just imagine that when we are saying links, it it is nothing but creating a pointers for a file or a directory. Okay, I hope now it's clear. So today we will discuss about pipes, redirections, wildcards, and links. Just to revise, pipes helps us to chain the commands, create a chain of commands by passing output of one command to the next command. Redirections helps us send output or input and from files. Wildcards helps us to match files with patterns. Wildcards, there are different wildcards helps us to match files or find files with patterns. And finally is links. So it helps you to create pointers for your files or directories. Perfect. So that is enough of theory. Let's jump directly for the practical now. Okay. So for this practical, you can create a sample environment and you can either use your local machine. No VM is required. So just let's copy this entire sample environment setup. What we are doing is that we are creating these directories and updating log1 file with some text and then creating multiple files. Sample text files we are creating. So let's create this. Okay. Okay. We have these um, directories created and files are also created. We can use these for our practical. So I'm just verifying everything is correctly. Log1.txt. Yeah, okay. Our environment setup is ready. Now what we are going to do is that we are going to do some practicals for pipes. As we discussed, pipe helps us to pass output of one command in as a input to another command. Let's take a basic example of it. What we can do, um, ls this directory Day11, and we want only log files from this. Okay, list files from this directory Day11 test, and we want only log directory or log file present in this. So we can do that. We can do a grep. Right? Grep helps us to filter. We can just say grep log and it will show only logs directory here. If there had been multiple other directories or files starting with logs, then we would have gotten that output. Okay? Listing files or directories, this is the usage of pipe. What we are doing here, we are executing the first command ls, which gives a list of all the directories and files present in this directory path. We are taking that as an input and passing it to the grep command. Now next thing what we are going to is that let's imagine that we have log1.txt file and we only want to see the error logs present in that file. How we can do that? We can cat this file log1.txt pipe and search for error. Okay, grep for errors. If we don't do that, it will simply print all the lines. But if we do a pipe, okay, so what basically we are doing here, so cat gives the content of this entire file. We are using pipe to take that as an input for the grep, which means we are just filtering the error logs from this file. I hope it's clear. Very simple. Output of one command will be act as input for the next command. You can also now do multiple operations, like if you want to count the lines and do wc -l. So this will give you how many errors are present in your file. Okay, you can also do a sort on this file. Okay, sort, or do a, let me remove this part. You have big file and you want to sort that file, and like this. Okay, if you wish unique entries, then you can do a unique operation here. It will show you the unique entries from file. That is how you can combine multiple commands or chain commands using pipe. Very simple and very frequently an operation by DevOps engineers. The next is redirections. So redirections helps us to change the where we want to send the output of command. Okay, so redirections change where a command gets its input or send its output, and it allows us to save the results to a file or to a read it from file or combine. There are different redirections available in Linux. Okay, redirection operations are available. So okay, first understand file descriptors or file streams. File descriptors are nothing but numbers given to stream. We have three streams available in Linux: standard input, output, and error. So 0 represents standard input, which means your keyboard from where you are giving a input. The second is standard output, which is nothing but your screen or terminal. Okay? And third is standard error output scene, which means where you want to see the error on the screen. So these are three streams, which means let's say I'm executing any particular command where I'll execute it on screen, right? And how I'm going to give the input um, my system using keyboard. So keyboard in this case is standard input. Output, which means where I am going to see the output of that command. It will appear on your terminal. So that will become standard output or the output stream. And error also, you will, if you want to see it on your screen, then it will become a standard error. Standard output and standard error can also be saved in file, right? So file can be sometime become uh, a medium to store the output of that command or store the error of that command. This can be sometimes terminal or file, but input you can only provide using keyboard, which means um, that is a standard input. Now this is, let me clear the screen a little. Those are file descriptors or streams which we have: standard input, standard output, and standard error. The next is redirections. As I told you, output of the command or the error of the command can be shown on the terminal, or it can be shown, it can be stored in file as well. For that we have different redirection methods or the redirection operators available. The first one is the symbol, greater than symbol. So it redirects standard output to a file. You executed command ls and you want to store the output of that command into a file, then you can use the redirection operator and store that into a file. Okay, and there is another operator, double um, double greater than symbol. So it redirects output to a file, but the difference between this first and the second is that it overwrites the existing file. Always remember, okay? It overwrites the file, this first one, and this second one, it only appends the file, append the content in a file. That is the difference. The difference between these and these operator is that it overwrites the content, existing content, and this one append the content. Okay, clear this out. The next is lesser than. This allows you to take file as an input. Okay. This is for file as a standard input, and the next fourth one is your to and greater than, which we'll see. Then if you wish to redirect standard error to a file, then you can use this. And if you want to redirect standard error to standard output, then you can use the combination of 2 and 1. Okay, so this will print the error to standard output and also, yeah, to a file. Let's check that out practically. What we'll do, we will execute this command ls and this ls command. This is giving us some output, right? But it is now printing it to on the terminal. This time we want to save that command output into files.txt or any file for that matter. So to do that, you can use redirection operator, give the path where you want to put it, if you check this file, you will see that the output is stored in file. This time it did not printed output on the command line, this terminal. It has stored that output of that first command into a file. Okay. What if we run this command again? So if you do that, it is going to overwrite the content. Can try some example, like I want to echo hello learners and store that into this file, same file. Let's do a cat. You will see that previous content has been updated now. If you wish to append the content, then you will need to double greater than symbol. Okay. Now, when we use the double greater than, it has appended the content. It did not overwrite. It simply kept the previous content and updated that file or append into that file. Then now the next thing is, for example, you want to grab the error without using pipe and want to take an input from file. Okay, I think previously I explained that only input can be taken from terminal, but input can also be taken from file as well. Okay, we are going to read the log1.txt file and provide that as an input to grep command and find out the errors available. Okay, that can be also done using input file descriptor. The next thing is standard error. So for example, if I do a ls for this file, it says that no such file or a directory, which means it is giving us some error. But when we do automation or run some CI/CD pipelines, we don't want the error to be printed on the terminal. Instead, we want to store that into some file. How we can do that? We can use the standard error file descriptor, which is nothing but 2, right? So by default, if you don't provide number 2, which means if you simply do like this, ls Sagar, and you are saying that you want to store the output of that command or into some file, then let's see what happens. Okay, if you do like this, it is still printing on your terminal. Why? Because you are not this is the error. This is not standard output, right? So you, if you wish to show the standard error, then you need to use standard error file descriptor, which is nothing but 2. Now when we do like this, 2 and greater than symbol did not print the error on the terminal, right? Let's check that. Yeah. Now your error is redirected into a file. For example, now let's say I want error as well as standard output to be stored into some file. I can use um, combination of these. Nothing but let me try this. I want standard error and standard output to be stored into a file. And I can use the combination of those. Sorry, need to redirect the output, and so this is how you will need to do. So in this case, what will happen if the file or the directory is present, then it will store that output of that command into this file. If not present, you will get error. Because of these operation, you are combining standard error and standard output. It will show that error to the file. Okay, so let me explain again. What we are saying is that I want to redirect output to a output.txt file. It's still when you are not passing any number, by default it is standard output, which is it is always 1 here if you are not passing any number. That is why it is assuming that you want to redirect only output to this file. Sometimes it can also give error. In this case it is giving error. So you want to store the error or output into file. For that you will need to use the combination of 2 and 1. Perfect. Now the next thing is wildcards. Wildcards in Linux. Let me clear my screen. Wildcards or globe patterns helps you to match files before command execution. So there are different patterns like star, which means any number of characters. Then we have question mark, it is for single character. Then we have these different ranges. Any character in this set. If that is matched, then return the output. You can also use anything between A to Z, any character in this range, or not equal to, not this thing, not this set of characters. Then you can use this glob pattern. There are complex glob patterns you can combine. Okay, so again, this is for any number of characters. This is for single character. This is any one character in this set. This for any character in this range between A to Z. Similarly, you can do number as well. And then the last one is any character other than this. It's negative case. Let's take some examples. Okay. Uh, I want to print all text files which are present in the directory. I can do ls Day11 underscore test. If I do like this, it is going to print everything, all the directories and files. But next time I want to print only the text files. So I can use star, which means um, any number of characters matching with this pattern. Okay. This time it is only printing the files which are ending with .txt. The next thing is I only want to print the log files. Okay, and then matching single character. I can do ls 11 start log. It will give me, okay, no matches found. It is saying no matches found. Is there any log1.txt. Now this time I want to print uh, the files which starts with log with the next character can be any number and ending with .txt. How I can do that? I can simply do ls is logs and log. Okay, log question mark is for one character dot txt. This time it's only printing log1.txt file because the star represent one single character matching. This can be anything, any character, and here we have one. You can try out the different examples I have given in GitHub repository. And Yes. The last part is links, which I already discussed in previous uh, days as well. So links are nothing but to create pointers to your files and directories. Um, hard links uses the same inode number for your main file and the link. Okay? And even though your link gets deleted, the hard link will be present. That is the difference between hard link and the soft link. File exists until all the links are deleted. In symbolic link, we create a pointer to file or a directory. But if you delete the main file, then it will break the link thing. Okay, so you can try out some of the examples from here. Create a file. Let's create this file. And then to create a hard link, use simple command ln command. Ln. You can verify this using ls. So here what we are doing, we are creating a hard link using ln command. This is going to create a hard link for this file. Okay, let me list this. Let's go test. If I do like this, and next let's create a symbolic link. Yeah, so you will see the difference here. What we are doing for the symbolic link, we are creating a link, and when you do the ls-ltra, you will see that it is showing this link is present, and it also gets represented using l character as the first character of this command output, okay? Which is nothing but a symbolic link. For hard link, you won't see it, it will appear as a common file or the directory. You won't see any difference. Let's try to delete this file, and it will okay. Before that, let me show the inode number information. We do I, it will show the inode numbers. Before these two files, we created hard link, right? We created hard link between these files. You will see that inode number is same for hard link, and for soft link, this is the one number. And if we try to check the inode number for these, s hyphen the inode number for symbolic link .txt file and for the other link is different. That is the core difference of hard link and soft link. For the hard link, both the locations of the file, it's the same inode number. They point to the same location on the memory, and for the soft link, you get different inode. Okay. If you try to delete one of the files for the hard link, let's try it out that. You will see that still it is printing. We deleted this original.txt file, but it's still printing the text which is there in the hardlink.txt because you only deleted one link for that hard link. It still have the other link. Okay, and if you try to cat again now for the symbolic link, it's saying that no such file or directory present because the link itself is broken now. Okay, so this link got broken now, and for the soft link or the symbolic link, you will get error if you delete the linked file. I hope it's clear. Now There are a couple of sample exercises you need to complete as part of the assignment. It's very similar to what we just discussed now. Okay. And once that is done, you can complete this checklist. Tomorrow we are going to check compression, archiving, and backups. And that is all for today. Thank you very much for watching this video. Till then, see you tomorrow.